Good afternoon, everyone. Okay, welcome to this class where we'll be discussing about class modeling. Okay, I'm Dr. Satish Narayan from University of Hyderabad. Okay, so as part of this class, we'll be discussing about object and class concepts, and then like link and association concepts, and then like generalization and inheritance. Especially in this video, we'll be talking about object and class concepts. Okay, so that's the agenda for this video. So the class model basically captures the static structure of a system. So I already talked about it. Okay, now we will try to discuss and then see the details of this one. Okay, we'll capture the static structure of the system by characterizing the objects in the system. Okay, and the relationships between these objects. Okay, and then like attributes and the operations of each class of these sort of objects. Okay, so we'll be looking at all these things. Okay. And class diagrams and object diagrams actually express this sort of class model. Okay. What these things are, we'll be discussing further. So, we already talked about what objects are. An object is a concept, abstraction, or thing with the identity that has a meaning for that particular application. Okay. Objects often appear as nouns in problem descriptions. Say, for example, if you are trying to develop a system and then like you are trying to have discussions with the customers, okay. So these objects actually appear as nouns in these sort of discussions, okay. We have to understand this concept, object concept, very clearly. Some objects have actually real world counterparts. Say, for example, if you think in terms of a person, okay. Say, for example, Satish Srirama, he is an object. If you think in terms of a person's as concerned, okay, all of you students, you are also objects, okay, in this case. Say, for example, all of you are persons. And if we are thinking in terms of an organization or company, University of Hyderabad would actually fit as one of the objects, isn't it? So some of the objects have this sort of real world counterparts, okay. In fact, actually visualizing these things is really relatively easy, okay, real world objects, because like you can actually see some counterparts there, okay. Some are actually conceptual entities. Some of the objects are purely conceptual entities. Say, for example, if we are trying to model a system where we are trying to monitor different simulations, okay, what are the software, computer simulations which are being developed, okay. Say, for example, if we have to take the object of simulation run 123, okay, what does it mean actually? So these are conceptual entities, okay. So there are no physical real world counterparts for that one. And there will be some of the objects which are purely introduced for implementation purposes. Okay. Say, for example, to implement a certain thing, okay, you need a binary tree. Okay, you have to create a binary tree class, and then like relatively you will be basically creating that object. What does it have? Does it have any meaning? I mean, in terms of physical reality, does it have any meaning? It will not have. Okay, so the objects can appear in any of these forms. We have already discussed all objects have identity and they are distinguishable. Okay, even though two objects have all the attribute values as identical, even then they will not be the same. Okay, even in terms of language constructs, we will see how it is. Okay, say for example in Java, like we will try to see a little bit later. Okay, so these are the concepts about objects. Then let us move towards classes. An object is an instance, or more or less like an occurrence of a class. Okay, class describes actually a group of objects. Say for example with the same properties, okay, which are attributes, also called as attributes, and behavior operations, which we have discussed already. Okay, and kinds of relationships and semantics. Okay, these are the things like which we will be discussing as part of this unit 1. Okay, in the coming videos. Okay, so a class can be, we already have seen a car can be a class. Okay, a person can be a class, a company can be a class, of which we have seen like what the objects could be. Okay, so these are the classes and objects. Actually, class diagrams provide a graphic notation for modeling classes and their relationships. Okay, that is about class diagrams. And object diagrams actually show individual objects and their relationships. Okay, say for example, we already said like an object is an instance of a class. Okay, and a class diagram actually okay, provides a graphic notation for this sort of modeling these classes, okay. And object diagram actually shows individual objects and their relationships, okay. Object diagrams are especially helpful for documenting test cases and discussing examples, okay. And within a class diagram, okay, so you would actually see like say for example, actually a class is represented by a rectangular box, okay. So here a person is put in a box, okay. So this is like the UML notation for that one, okay. So person is a class here, and then like the person class has multiple objects, isn't it? Say for example, Satish Srirama is a person. Michael Blaha, who was the author of this book, okay, one of the two authors of the book, along with James Rumbaugh, okay, is also an object. If at all we are considering person as an object, okay, a person as the class, then Michael Blaha is an object, and there can be an anonymous object as well, okay. So these three are the objects, and this is the class, and the representation UML representation is also shown here, okay, in this slide. Actually, if we are trying to represent a class diagram, we will be putting only this person. If we are putting in objects, all of them together, okay, so this is the object diagram. You can see like this. With, say for example, if in the system like there is only one class, okay, that's the class that. If that is the case, a class diagram actually corresponds to infinite set of object diagrams, because there is no limit to the number of persons, okay. There is no limit to the number of objects which actually can be created with this person class, okay. Hope that is clear. Let's move on. So each of these classes, okay, and also the objects will have attributes, isn't it? An attribute is a named property of a class, okay, that describes a value held by each of the object of that class, okay. If we go with this sort of person class, okay, okay, so it has a name as one of the attribute, which is of the type string, and it has a birth date, okay, which is of the type date. Now, if you really go towards the objects of that particular class, say for example, Satish Srirama as a person, as an object here, okay, of the type of the class person, has a name and has a birth date. Similarly, some other person, Joe Smith, also has a name, also has a birth date. Okay, so these are about the attributes of a class and relevant values for those particular objects. Okay. So this is again the UML representation of a class, okay, and the attributes are actually shown in the second compartment of this sort of box, okay. So the person is a box, okay, and then the second compartment are the attributes, okay. Same for the objects, okay. So if you have already noticed, so the objects, they are actually underlined, okay, with respect to class, okay. So this is the object name, and then like with the column, and then like person is the class. Okay, there is an underline for that one, and then like again in the second compartment you have the exact values of that particular object for those particular attributes. Okay, that's about attributes and values. Along with the attributes and values, okay, the classes will also have operations and methods. Okay, we have quickly discussed those things in the last videos, but then like let us go deeper into those concepts. An operation is a function or procedure that may be applied to or by the objects in a class. So basically, like this person class will have certain operations. Okay. Say for example, a person class can have change job as an operation, change address can also have as an operation. Okay. All objects in a class actually share the same operations. So Satish Srirama as a person object, okay, will have the same operations, okay, and another person, say for example XYZ, will also have the same operations. Interestingly, the same operation may be applied to many different classes, okay. Here is a class called file, okay. So such an operation is actually called as polymorphic, okay. That means like the same operation takes on different forms in different classes. Now think about a class which is like file. So if a file is a class, then it will have a file name, okay. It will have size in bytes, okay, different files, okay, different sizes, and then like when is the last time like it has actually been updated, okay. So it is a very clear concept. But file will also have a print operation, okay, printing the file. But the issue is printing an ASCII file is different from printing an image file, isn't it? So basically, like the file as a class will have this sort of operations, okay. So now there can be subclasses of this file. What the subclasses we will discuss further, okay, down the videos, okay. But the idea is like there can be an image file, there can be an ASCII file, or there can be some other file. Okay. So how you actually implement the print operation for those particular classes and those particular objects will be different. But the interesting thing is all these methods should have the same signature. That is something like which we should not forget. Okay. Conceptually we'll see them. At the same time, like even in Java language, like we'll try to implement them. Not immediately, but then like when we actually come to this sort of discussing get classes, extensions, and then like all these things. Okay. So inheritance and those aspects. So once again, a method is actually the implementation of operation for a class. Okay. So sometimes like I am actually interchanging these two things, operations and then like methods. But then like when we discuss about class, then we talk about operation. Okay. And a method is an implementation of an operation for a particular class. Okay. These are about operations and methods. Now, if you try to put all these things together, okay, and if we really look towards this sort of notation for classes, the classes will be represented by these boxes, okay. In the first box, like you will first compartment, like you will have that particular class name, okay. In the second compartment, like you will have these sort of attributes, okay, and attribute name one, and then like what is the data type. Say for example, in the earlier case, like we have seen, like name is a type string, okay, and you can even give a default value for that one, okay. And then like there can be attribute name 2, okay, which is of data type 2, and it will have again another default value, okay. And then like once we come to the operations, so we will have this sort of operation name 1. It will have this sort of argument list, okay. Say for example, you all know about C, so whatever the method you give, like you have to give this sort of argument list, isn't it? Okay, parameters for that method. And then like you will also have this sort of result type, which is like a return type, okay, in certain languages, okay. So and then like there can be multiple operations as well, okay. uh, Methods will have these sort of arguments, okay. So within this argument list, like they will be separated by commas, okay. An argument can be of this type, so it will have a direction argument name, okay, whatever the argument name, which is of the type, okay, whatever is the type, and it can also have this sort of default value. The direction is actually interesting in this sort of class notation. Direction actually indicates whether the argument is an input, okay, because like within an object, within an operation, there can be several parameters. The parameter can be of input type or an output type, okay, or an argument that can be modified. Say for example, like you basically send another class object to this one, and which can actually be modified. Okay, so in that case, like the direction will be like in out. So thank you very much for your attention. So this is the reference. Okay, so this is the again like Michael Blaha and then like James Rubanko, object-oriented modeling and design with UML, and this excerpt is taken from chapter 3. Thank you very much for your attention.